In this example, we'll use the limit comparison test to determine the convergence of this series. In the limit comparison test, we'll be choosing a series which we feel like this should behave like. We'll find the quotient of an over the series bn, which we'll pick. We'll say this behaves like something. We feel like it should behave like something. We'll take the limit. If that limit is 1, then that means that those two actually do behave the same. That's the limit comparison test. If I'd like to say what does this behave like, well, I'd like to say it probably should behave like the series which has the largest degree terms in the top and the bottom. So we're going to let bn be 9n squared over n to the fourth. The largest degree in the top and the bottom. And in that case, the limit, as n goes to infinity, of an over bn will be 9n squared plus n minus 1, so is the limit as n goes to infinity, of 9n squared plus n minus 1 over n to the fourth plus 3n squared minus 6. Then divided by bn means multiplied by the reciprocal of bn, so that's n to the fourth over 9n squared. What is this limit? Well, this limit is in fact 1 because the largest degree in the top will be 9n to the sixth. The largest degree in the bottom will be n to the fourth times 9n squared, which is 9n to the sixth. So this is the limit as n goes to infinity of 9n to the sixth over 9n to the sixth, which is 1. Since we've found something which has the same limit, or which has a limit of 1 after taking the quotient, that means that an and bn have the same convergence. Either they both converge or they both diverge. So now let's look at sum of bn. Sum of bn from 1 to infinity will be sum of 9n squared over n to the fourth. Well, that's sum of 9 over n squared. By canceling an n squared. This is a p-series with p equal to 2. This is a p-series with p equal to 2, which is bigger than 1, so it converges. So 9 over n squared converges, so 9n squared over n to the fourth converges, so bn converges. So that tells me that bn, sum of bn converges, which means by our limit comparison test, since the limit of an over bn is 1, that means that sum of an converges as well. So the big idea is say, what does this behave like? Let's take an over bn. If the limit is 1, that means that they do in fact have the same limit. They do in fact have the same convergence or divergence as this series.